So anyways, as I mentioned before, we just talked about before the program, the screen flow crash, we talked about orbiting. We talked about apoapsis is way out here. Periapsis is right here. All right? That's a apostasis. I'm probably saying apoapsis. You're farthest away. And that's where we generally like to be when we're doing docking maneuvers. Periapsis is close, but there's a lot more gravity, and we get this impact right here. I don't know if that's what was messing it up, but there it is. Okay. All right. As the planet goes around, as this a little ball comes around here, it's going to be much faster than the red ball. All right, and that's where we're going to change things. Now, and this is at its orbital velocity. In other words, this is the fastest. So we change it to get into orbit by little adds of energy, turning it on or off. If you ever see Apollo 13, great movie. You see they actually do this in the movie, trying to get it back. They're doing all these calculations to calculate what the burn is. All right. To get height in our orbit, it doesn't mean you go straight up, folks. One thing I want you to see when you do this, you're going to go to your right. All right? So when you go straight up, to get altitude, we're going to use this fact that the Earth is spinning to our right, if you're taking out from here, and we're going to go with the spin. If we went the opposite way, we would have to use more energy. Think of it this way. If I was standing and you were in a train, and I'm standing and the train's coming by me, you're playing ping pong. In the train, it's normal speed. You're hitting the ping pong back and forth. But for me, outside the train, the ball is going to go as fast as you're playing ping pong plus the speed of the train. So we want to use that to our advantage. All right? That's what we add those vectors together. And what you don't realize is the Earth is spinning kind of fast, but it's all we've ever known. All right? So that's, to me, is pretty neat. Is you've been on a spinning planet that goes really fast. It just, we all recognize it. All right? Quick question before we go any further, too. How many people went to lab last week? And how many people liked the cat? All right. Got about half of you did. How many people liked the casting and molding? Great. That's a pretty cool technique. And if you really think about it, you were doing 3D printing with a Raspberry Pi. 3D printing with a casting and molding technique that's been around for ages. Quick question, Cooper, did you get your 3D print? Is Mr. Maurer going to do it, or do I need to send it to you? And I'm happy to send it. I'll print it tonight. Just let me know, Cooper. Write me an answer so I can see if you got it or not. All right? I thought you were the one person that we still hadn't gotten a print to. All right, great. Mr. Maurer's printed. He's a good man. Okay. Now, change your trajectory to lower the height of an orbit, like when trying to re-enter an atmosphere, involves burning fuel opposite direction of motion. This is called retrograde. If you're going forward in motion, it's prograde, yellow circle. If there's an X in it, you're going retrograde, so you're going the opposite because you're trying to slow down. So, when would you need a higher delta to change your orbit? When the orbit is closer to the body, or when is it farther away from the body? Go ahead. I just mentioned this. Well, tell me what it is, folks. Write an answer down. All right. Come on, folks. Lauren, Cooper, John, Luke, what do you guys think? Faster we get going through this, the faster we can start launching things. Today, I'm worried that it's going to take us this long to get through it. We'll only start. All right. When would you need the higher velocity? When you're closer or farther away from the body? Folks. Absolutely. Those people who say closer are absolutely right. You're going to need more energy. Look at this. Watch this image. See this? If you're close, that thing's really catching up in speed. You're gonna need a lot more energy where it's slow out here. So just remember, we're gonna use that to our advantage. All right. We did that. Let me go back here. You'll need a higher delta V closer to the body. The force caused by gravity grows stronger the closer you are to an object. It's called the orbit effect. I just mentioned it before. So you use a lot less fuel to get in a higher orbit. You'll need to be at the highest point, apoapsis, of the object's current launch. Don't worry, we'll do this during our launch. We'll see this. We want to get as high up as we can, because then I'll use less energy to move, because we're not getting pulled by gravity. All right, we're going to go ahead. I'll show you. I have one right here. We're going to go ahead. Everybody, please start up Kerbal. Raise your hand once you have Kerbal up and running. And we're going to go through this right now. I'm going to go through the plane we're going to do. All right? The plane. And the rocket I want to do. See, I'm a rocket plane guy. All right. Okay, so here we go. Let me go ahead. Go to Space Center. You can also revert to flight in this. And when you start crashing, I would suggest you revert to flight. You don't have to start all the way over. Waiting for people to get here. So, I have a new one. I'm going to do a new one just because. Hey. Let me see here. Well, that's not what I want. I'm a Mac. Hey guys, if you can. Let me turn this volume down. Alright, there we go. Sorry. You know. Alright, now let's go ahead. I'm going to name this aircraft. And you can go ahead and save it, give it a name. And you can just say orbit or orbiter. Something basic. All right, folks, raise your hand if you're in the program, because I'm waiting for you all, and so is everybody else. So just let us know, so that way we can all get together on this. All right. We're in Kerbal. Where do we raise our hands? If you shrink Kerbal down, you hit the little green on my Mac. I forget what it would be in a window. Shrink it a little bit, and then you can bring this back up. Up here, you right. All right. All right. Good. We got most everybody then. And I'll assume, unless you start sending me questions, hey, I'm not with you. All right. So, let's do a couple things here we're going to talk about. Command pod. All right. Mark 1 command pod is perfect for this. All right. I want to make sure that, what is that over here? Let's get rid of it. Okay, I just want that command pod. I'm going to go to utilities here. And then I'm going to find my little parachute. Mark 16 parachute. And this is really small, so I'm going to blow it up a little bit here. That's plus there. Let's see if I can get it. If you hit the plus key, you can get it up there. Alright. Now, right there we have our... That's 0, so that's parachutes above. our hub right there. Now, the next thing we're going to want to do is a TR18A decoupler. So again, we're going to go structural. And you might have to clip up to find it, but there's our TA stack decoupler. Click it up there. All right, so we've got it there. The next thing we're going to get is the FLT400. The FLT400. All right, that's the engine we're going to use. I mean, it's fuel tank, excuse me. All right, that's not it. It looks a lot like the one we want to use. Here's the one we want. The FLT400 fuel tank. Okay. We're going to grab that fuel tank. We're going to put it right on here. There we are. Again, it's green. You just click, click. All right, no big deal. Then we're going to go over to engine. All right. And we're looking for the LV909. I'm going to bring that over here. We're going to show you why we're using that one. If you started to look at it, it doesn't get that much thrust. But what's great is the gimbal limit. This has gimbals. That allows you to thrust the bottom of it, and it can turn. So it makes it really much easier to turn this rocket when we need to. So this is why I want you to use this rocket, the LV909. Please use this rocket. All right. Let me go ahead. I'm going to not be able to see you all while we build this rocket. This way you can see it. So there's the LV909 Terrier liquid fuel engine. All right. It's gimbaled. All right. Now, it's kind of wild as you go back over here. All right. Fuel, that was an engine. Those are the fuel tanks. We're going back to structural. Go back up here and find our stack decoupler. Put it right there. And it covers over the engine so you wouldn't see it. So there's your stack decoupler. Make sure you take a moment and put it in there. Then, and that's the TR18. Okay. Now, once you have that, we're going back up to our fuel tanks again. All right, and again, the fuel tank we want is the FLT400. At least that's one I use. All right, one. Then you can take another one here. 2. And 3. Okay. So let me take a moment so you can all get caught up. So we use the 909. All right, let me make sure I didn't just tell you something wrong here. I'm sorry, guys. I'm going to pull this over here. Let's see what engine this is. Right click on this. That gimbal needs to go down here. This needs to be the 909. All right, let's find this. I find my motor here. You know, I don't really like how they filter this. That's solid. We don't want that. There it is, the Terrier right there. Sorry, that was the one we wanted there. That's the 909. And it's gimbaled. That's the 909. We wanted it there. And then we want the LTV 45 after we put these up here. Okay, let's get out of here. Oh, let's put that up there. Put that decoupler back on. There he goes. No harm, no foul. Boom. This is the 909. And we want the LV45. So we could have left it. I think I'm overthinking this. Sorry, guys. So there's 909. All right. LTV 45. All right. We'll put that one in there. All right. All right. This one has some more vector. So you can decouple here, and you can decouple up at the top. So there's two different places we can decouple. We can see them all right here. All right. There's a decoupling. There's a parachute. All right. Now the next thing we're going to put on there is launch and stability structural. All right. And that's a radial. We're going to use a launch stability enhancer. This one allows you to put the rocket so it's going straight up and down. So we do that. I'm going to go down here. I'm going to select. Wait a minute here. Let me go here. I'm going to go symmetry mode. That's 3, 5, whatever that is. We're going to just do 2. I'm going to turn around until it turns green. You click or press enter. There it is. All right. You also could put some fins on this if you wanted. And again, same kind of idea that we're trying to make this thing as, all right, a basic fin on this. Go down here. We can do 3. Put them right here. Well, that was 2, so that shows you what I did wrong. Oh, jeez, Pete. Let me take that off here. Go down here, 3. There we go. Make sure it's green. Pop. Why am I getting only... There we go. Thanks, Mr. Dubik. Do you really know what the heck you're doing? All right, so there we go. There's some fins. Because of the engine, you already have a SAS to help your symmetry. So this will all help you when you launch. Now notice, we want these to launch at the same time. No, I want to get rid of that. I don't want 2 of these. All right. It's got it here and here. It looks like that. So when we go out to launch, let's save it orbiter. Go to launch site. I'm going to clear launch pad because I was just lying. Ready for sun. Done. Let's go. There we go. Here's my launch. Fins ready to go. We're going to talk about, I'm going to escape down so we can all see where we are with this. All right. Go up here. I'm going to shrink this window down to see where you all are. Let me know if you're at that point. Where I am. You're on the landing. You've added all this stuff. Raise your hand once you have that. What we're going to do is try to get as far along as we can, and then we'll practice orbiting tomorrow or Wednesday. And then next week in our final lab, we can talk about going to the moon or playing with that. Okay? Plus, I also want to see what you thought we did well in the class, what we need to improve it. Okay? All right, I've got about 6 out of 9 people saying they're set to go. Let us know, everybody else. We're closing on the 7 o'clock mark, so I think we're going to be, I'd rather we get it so you start. All I want you to do is get the V velocity vectors today, and if we don't get any far of that, that's fine. I would rather we all get to that point. Okay. Now, couple things we're going to need to do. All right. As we sit and do this. All right. Some people will give resources up here. Not sure why you need to. On this rocket, right? Well, let's resume. If you go up there, that'll show up your resources. Down the road, you can track that. So people have asked me about that. This is our speeds. You notice we're only 87 meters off the ground. The thing I do think you really want to look at, just review. This is all set. So watch, I'm going to just launch it real quick. You want it when you launch These two have to be together because watch what happens. If they're not together, you're jammed. You know? And then it just didn't. Well, you know what happened? Mr. Dubek didn't have his fuel up. So let's go back on this. That's hilarious. Revert flight. So we go. Return launch 55 seconds ago. I'm going to go back to that. All right. Let's pull it up again. Let's make it green so you can see what I'm doing. All right. So here we go. I'm hitting the shift key. Watch what my throttle's doing. This is just to give you an idea of what the launch is going on. I'm going to turn around like this. All right. I'm up full throttle. See how those all let loose at the same time? And I want you to see, we're going to be worrying about this miles per hour is it. We also would be helpful if we put on the stability on this. Our little fins helped out quite a bit. But our SAS is on there. And notice we're just getting to 1,000 feet. We'll start hitting the control key because we want to be at about 150 when we get to 5,000. I'm actually a little bit slower on that. Don't worry, you're all going to get a practice doing this. I'm just trying to get you a sense of what we're going to be worrying about. We're going to be coming up, watch me right now, folks. You're going to go up to 5,000. We want to make sure we're right there. We don't want to waste a lot of energy. I'm going to hit a little bit of shift. A little bit slow. Alright, so you want to be at 5,000. And then at 10,000, we want to be at 250. So we're gaining speed here. So we're at 7,000. And we're going to come back to this. There's not everything we want to do. All I want you to do is watch me right now so you can play it. So we're at 8,000. Notice my speed is gaining up here. Throttle. I'm almost there. Almost there. I'm at 10,000. Now what I'm going to do, all right, having done that, I'm going to use my D key and go about 45 degrees. Excuse me. 25. With that stability system on, it... Okay. So we're now at 20,000 feet. We're going to be at probably a little more speed. All right, let me get out of this flight. I'm reserved back to launch. All right. I'm going to go up here, shrink this down. All right, folks, putting your hands down. I want you to go ahead and launch. Listen to these numbers. Write a note to yourself if you need to. At about 5,000 feet up, you want to be at about 150 meters per second. Remember, here's the surface. We're looking at it right here. Then, as it goes up, as you get to 10,000, you want to climb that up to 250. You'll probably be using less fuel. And then we're going to turn it over onto its side at about a 45-degree turn. So we're not going straight up because the Earth's going. We want to get at it. We want to get in the same orbit as the Earth. So we're going to turn over to our right, not our left, to our right. And with the SAS running and with those fins, the plane rocket's going to be very, very stable. Okay? So, go ahead. All I want you to do right now, we got to set up the orbit and some other things down the road here. I want you to go ahead and launch it. All right? Do the things I just said. Just go up, practice the launch, see if the rocket comes off the pads, all that good stuff, okay? This is an unbelievable program. It's both fun and whimsical, but the orbital mechanics are dead on there. So let me know once you've done that. And then we'll start setting this up for what we're trying to do. Raise your hand once you've done it. All right, we've got some folks ready. Let us know when you're ready. All right. All right, let's everybody go back. If you right click, hit escape when you're Kerbal, make sure you revert back to flight. That'll take you to launch. All right. Now, a couple things we want to do here. Okay. First thing, we're going to hit M. We're going to zoom in. Oh. We're going to zoom in on Kerbal. I'm going to right click and move it around a little bit, right? Oh boy. All right. I'm going to double click so this way I can spin this world around, not so much the orbital. All right. So zoom in on that because it'll make it useful when we go to launch. And if you right click here, it'll move you around. Okay. Let's move it over here. All right. There's where I want to be. I'm going to zoom in. Okay. Then I'm going to pull this bottom arrow up so I have that with me so I can be watching. I don't want to be doing this in the middle of the launch. I found that really is a good tip. The people that showed me that. I was like, yeah, good idea. All right. So now I've got, so we have that. So I pulled that up. So we have this. Now I'm going to hit M again. So I'm at the launch. I'm going to turn myself around. I've got this here. You can have the resources up there. I'm not sure why you would bother with this flight. We can watch our fuel burn over here. So don't worry. We'll be able to see when it goes. All right. Hit T for turn on SAS. And, you can start playing with that down the road. Let's not, stability assist design is what we're looking for. Okay. What we're going to do is we're going to launch. Get it up to 45. We're going to be there for a while. So what we're going to do, remember, 150 meters per second, which is quite fast, folks. 250 at 5,000, 250 meters. Start gravity turn, be at about 45 degrees. Then we're going up to about 20,000 meters up. We should be at about 700, be around that. And then at 30,000, we'll be up at 20,000, 2,000 meters per second. Don't worry if you're not quite there. All right. A couple things on your throttle. Shift up gives you full throttle. Control takes you down, which I know I've talked about. Also, X turns you right off. As you start to do some maneuvers, you'll want to be able to know that. So shift is up. Okay. All right. Let me see what questions we have here before we get rolling. Okay, everybody's fine on the questions. So, I've got my throttle on. I've got my map. Here, I'm going to go over here so you can see it. Make sure you have map of my Kerbal, so when I come up, won't have to look for them. I'm there to launch. There's nothing wrong with saving it right now, so that way you don't have to redo this every time. In the beginning, it's good to do it just so you learn how to do it. Okay, staging set. Throttle's up. Okay. There we go. We gotta make sure my shift. I want to make sure. Okay, good. 3, 2, 1. There we go. With all our stability, our rocket's going straight up. It's at 30 miles. This is why you watch a real launch. You'll watch an Elon Musk launch when they do SpaceX. You'll hear him talking about these things, which is kind of fun because now you know what they mean. All right, so it's going up. We're only at 1,000. We're kind of getting a little bit faster. I'm going to control down a little bit. I don't want to overshoot it that much. I'm taking it down. I'm going to save some of my fuel. I'm a little bit fast, and I really would have not liked that. Okay, at 5,000, I should be at 150, so I literally overshot this. All right, now it's going to keep climbing. I'm going to go to 10,000. Hit my map. There I am. All right, I'm at 171, 70. I'm climbing a little bit more. I want to get to 250, so I'm going to add a little throttle there. Okay, when that happens, now I'm going to hit my D key. Again, with this turns, whoa. All right, let's go ahead and turn. Okay, so I'm at 45 degrees. I'm still gaining. I'm watching my fuel. It's going to burn off in a minute, and then I'm going to eject that part of it. I'm climbing back up because I got a slow start now. I'm not quite at 700. All right, there we go. I'm going to burn out my fuel in a minute. I'm going to keep going. Ready, set. I'm going to pop that off. I'm going to keep my 45 degrees. Now I'm at 30,000 feet. I wanted to be going faster than this. So Mr. Dubik blew it on that opening round. So let's see where we are on this. See how... Okay. I'm going to see if I can add a maneuver and pull this out. If I do prograde, what do I got to do? I'm going to pull that back in here. Oh, man. All right, go ahead and try that. I'm going to launch mine back up. So, I'm going to go back to revert flight. I'm going to play with that one again. All right, hit M. I'm going to zoom in. There we are. Double click here. So that way we can move the Earth around. Pull this up. Good deal. Go back. I'm ready to launch. Go ahead. Here's set here. Let's go to full throttle. So we always take off there. 3, 2, 1, launch. And what did I not do? Got to keep the stability system on there. It's correcting. We're still all right. I'm going to do a little bit of a... And then I'm starting to get a little bit too fast. See how I went too fast? So it's really easy to blow it, as Mr. Dubik just clearly did. Try it again. In all seriousness, I've just done it 5 times in a row. All right. Let me know when you've gotten up there. And you can consistently do it. Some of you guys have been doing this a lot, probably going to do much better than the rest of everybody else. Probably me included. All right, here we go. See, it never even drifted. Not used to this one engine. It's flying definitely more powerful than the way I had it arranged earlier today. All right, there we go. 5,000. I'm going to be at 150, a little bit fast. 6,000. We'll give it a little more up, a little uppity up. Okay, we're at 10,000. Now I'm going to slide myself over 45 degrees. It's really going to stay here for a while. Notice my prograde is now bending over to that. My speed is up. I'll go ahead and hit a little bit more fuel. And as long as it's, you know, we're at 500. All right, there we are, 20. Okay, see what? Isn't that awesome? The speed we have. Boom. We pop that off, and we're still going pretty quickly here. All right. Okay, I've only got a couple people been able to pull that off. Why don't we get everybody? I'm going to pause mine. It's going to fly out of here in a minute by doing this, but let me hit escape. All right. We'll give everybody a chance to catch up. No worries. This, we want to be 40 and 50 when we get to aposis, by the way, at 54,000. So we're pretty good shape there, actually. If I look back at this, and I'll give everybody a chance to go back. I'm sorry, I'm interrupting you a little bit. But one of the things you want to do is put it over there and see what your aposis is, okay? Apoapsis, and I keep saying it poorly. I apologize. It's going over there. It's between, should be between 40 and 50. I can do things now to either power it down or flip the rocket on its side. We can do a couple different things to kind of get that. Keep that between 40 and 50. Remember, just real quick, I will show you this. Apoapis is the farthest away from the body it's orbiting. And that's where we want to be on this thing, okay? Because it takes less energy, right? Since it'll take less energy to make our maneuvers, we'll be set there. If I look on my rocket, let's see what kind of power we've used. Resume flight. Let's see what are my times doing here. Yeah, my time's 44 seconds. That's pretty cool. All right, so what I can do is and I may mess this up because I'm going to play with this a little bit to demonstrate some things. All right, if I pull him over here, I can pull him on his side a little bit more. Watch what happens. Here we go. Let's try to do this. Oh, I didn't mean to do that. All right, so here he goes. I've launched that one. He's going. Still haven't used that much fuel. I'm going to go turn on my side a little bit more. Then I'm going to hit M. Let's see where Apis is. We're at 43 seconds. That's pretty good. Okay? All right, and if I look at my rocket, I still have a lot of fuel. And it's 51 seconds, so let's go back. Here we go. So let me experiment here a little bit. So if I would do this, all right, let's go back and look at our map. That made it a minute too, so that's not as good as we would like. Hit map again. Let's try this. Let's see if we move it this way. Let's do an experiment there. Map. And see, that's minute and 26, so that made it worse, didn't it? So let's go back here. I'm going to pull this over on its side. Probably add a little more fuel if I can. Alright, let's go on our map. You can see it's starting to come around the world. And now we're at 3 minutes. So you can see what starts to happen. It gets away from you. Me monkeying around with it, we had it just fine. I start playing with it, and now I'm like a minute and a half from there, which isn't probably... And look at it, it's escaping me right now. See? And it's going to come around in a circle here in a minute. There it is. It's 17 minutes for me to get to Apoapsis. So I'm almost going to end up... Honestly, almost in orbit, really. Okay, so there we are right there. So you can kind of see which way we're going right here. We're now coming around the Earth, though we really... Alright. And what you can do is you can right-click here. Let me right-click on this. That's Periapsis. Let me get over here, Apoapsis. So I've messed around with this. Alright, there's my orbiter. Velocity. Okay. And see how far away that is? That's a problem. We want to be 45, 50 seconds. I mean, we're kind of far away there. Which is, I mean, you really want to be 40 to 50 seconds. We're way off. And so what we can do on this, though, let me pull around here if I can get this on the screen. So there's the PE and there's the Apoapsis. Add a maneuver. So if I pull on that, what we want to do is get this maneuver, which you can hardly see here because I've messed playing with this. I've got to sew out a thing. You want to get this maneuver to match that orbit. We don't have the power because I've gotten the orbit so far out there. So basically, I haven't orbited. I've got myself way out in the deep space, which is probably not what we want. All right. So you can see out here, look what's happening here. And here's our maneuver. We would have to wait. If we pull this, we'd want to get it so... You basically would want to get it so it pulls out to here. That this maneuver will tie in with the blue line. With Mr. Dubik experimenting to demonstrate that, I've made it, well, ridiculously. It's 93 days. Look at that. So that'd be a bit of a problem since our Kerbal guy wouldn't make it. So I'm going to go back to revert flight, and I'm going to go back to launch. You could also save it before we pulled it back up. Now I'm going to escape down because I'm not going to worry about it right now. I want to talk. I want to go through this with you all. All right. Let's see. We got some more questions. I hit the moon too hard and died. How did I fix that? I was trying to orbit. Well, you learn how to orbit the Earth, and then we'll start doing that. You probably needed more what's called retrograde. You went prograde. You ran right into it. Remember, you retrograde your rockets are going the opposite direction of which way you're moving. So let's come here, everybody. Let's take a look at this, and then we'll just practice this part of it. So Wednesday we can get the orbit down. Then we can talk about the strategies going around the Earth. And then next Monday or next Wednesday we have another lab. All right. And if you need me to, I'll have an extra lab to show you how to do any of this stuff. All right. So we got in here. All right. So first. Oh, wait a minute. Make sure you hit that nav ball. You have the M. Make sure you have that. Again, watch your altimeter. You know, it's under 10,000 atmospheres thickest. So keep your surface speed below 150, and I would say at 5,000. I think you get to 10,000, I'd go 250. Carolyn's doing this. Make sure you have the SAS on before you launch. All right. And some people turn it off once they get it because it makes it a little bit easier to maneuver once you get out in space. Turning the SAS off. I think that's a personal choice, to be honest with you. See, Carolyn, who another teacher teaches, says, hey, turn it off. All right? And make sure you see 45 degree. Make sure on your orbiter, you know 45 is more the top of that nav ball. It's not the bottom. All right? Make sure you throttle up that smaller engine. So there's a lot to practice. I don't really get wound up about you orbiting on this first lesson. I would rather you get through the steps and start playing with things. Okay, if I'm where I think I need to be, it's 49 seconds, 44 seconds to reach. And that's what you're trying to get to apostasis. And you want to get there between 40 and 50 seconds. Have that set to go when you do your first maneuver. So your first maneuver, you want it to be between 40 and 50 seconds. And I'd rather you practice, because I was messing around with it, and I got so far off, I ruined it. Plus, the minute my first rocket motor launched, I should have hit the second one. But when you're trying to teach something, you're worrying about what you're teaching. Hey, somebody's orbiting. Great. Jason, 9. Good job. So Jason had his first orbit. Excellent. So it'll say orbiting when you're playing with it. So again, you see that blue line. You want to do a maneuver that matches that blue line, and it'll click, and then all of a sudden it'll say orbit. All right. It's almost 7:30 now, 6:30 your time. We'll be here Wednesday. If somebody knows Philip, have him email me so I can go ahead and get him his software. You don't think you're doing it right? Don't worry, John. We'll help you out there. All right? Practice doing what I was just having you do, and I will pull you through these. Because, see, let's look at this real quick before you go. Don't worry about all this other stuff. Worry about prograde and retrograde to begin with. All right? Let's just keep it. And then what you're going to do, as you start to do your maneuvers, we're going to look at what's called burn time. You're going to be at a certain angle, and it's going to say if you want to get from your orbit to match apostasis, an orbit on Earth, you want periapsis and apostasis to be about the same, equal away from each other. And we'll show you why Wednesday. You're going to have a burn. You're going to have to watch it. I really can't stress enough, you appreciate launches once you start doing this. Yeah, I ran out of fuel really quick. I think you need to get over the right. Remember, we got 2 rockets. All right? My rocket exploded when I was in space. You're probably going too fast. Don't be playing career mode. Well, you can play career down the road. That's why I bought you the full game. But right now, do the sandbox mode. All we're trying to do is get the science and engineering of this. All right? That's the other thing I want you to see. All right? And see, look at this. You're trying to get your move to match that blue line. Once you've found the directions, get in space, like the M button on your keyboard, you'll find a trajectory in blue. Hover on the app mark. This is apostasis, which will show you altitude. Select X to kill your engine when apostasis hits about 100,000 meters. We don't really talk about that. and then click on the app marker and click add maneuver and click the green prograde target and just keep hitting it until you nail it. All right? So that's a lot to get the first time through. Don't worry about it. And drag to the right. Oh, shoot. I want you to see this note. My mouse keeps doing that. Keep dragging until you reach around Corbin. So you get your maneuver. That yellow line is going to go all the way so it goes around. You know, and then it's going to give you your burn rate and stuff. And then you're going to wait to that point. It's going to give you the time you start the burn and when you do the burn, full burn. And you go, you know, when it gets less than 10 seconds, turn on the burn. Okay? How many people, put your hands down, how many people like the Kerbal stuff? Like what we're doing here? That helps me know. Okay, so it's very popular. Most everybody says they have enjoyed it. It's a little bit frustrating in the beginning. Hang loose with it. It's a real sense of accomplishment when you can orbit and you can land on the moon. Landing on the moon is, we got to really get it so you can orbit the moon first. Or MUN, as they call it. Okay? And these calculations you're doing, we have this computer helping us do the calculations. The astronauts in Apollo 13, when they were landing it, they were doing it with a slide rule and a pencil and paper. And just think about the pressure. They were sick, they were cold, they were exhausted, and they're having to do these calculations to make sure the burn, they had to know when did they do a burn and how much time. And that was not a trivial thing. All right? That's why all right, that's all I've got for today. Take care, everybody. I'm glad you enjoyed it. We will meet next. We'll meet Wednesday. Then have one more webinar after that, and if we need more, I'll happily give it to you. Okay? Take care, all.